motorcycles, the torque and RPM of a wheel is controlled by manually shifting gear levers up or down with our left foot. Motorcycle gearbox comprises of a series of different gear steps, which can be switched according to the requirement. The gear lever is connected to a shifter shaft, and the other end of the shifter shaft is connected to a ratchet mechanism. This ratchet mechanism activates as shown in the animation. The purpose of this ratchet mechanism is to rotate the shifting drum at specific angles. The shifting drum has special shaped channels cut into it. Special attachments known as shifting forks fit into these channels. Gears known as gear dogs or dog clutches fit into these shifting forks. As the shifting drum rotates, the shifting fork along with gear dogs slide sideways as shown in the animation. The purpose of sliding dog clutches will be explained shortly. First, let's understand the arrangement of different gears in gearbox. There's an input shaft and an output shaft. The gears are arranged with their axes aligned to their respective shafts. Some gears are internally splined. These splines perfectly mesh with external splines of their respective shafts. These splines allow gears to slide from side to side while maintaining the same angular speed as the shaft. All gears which are shown here in red color are splined. Some gears are freewheeling gears. These gears can freely spin about their axes, but cannot slide sideways along the shaft. Gears shown in blue color are freewheeling gears. The remaining gear is a static gear, which is attached to the input shaft. Let's number all these gears from 1 to 5 for better visualization. Please note that all freewheeling gears adjacent to dog clutches have recesses. The dog teeth can slide into these recesses and lock these two gears with each other. Now let's see how power is transferred with different gear ratios in a gearbox. One thing you can observe here is that every splined gear is meshed with a freewheeling gear. In this condition, if we spin the input shaft, no power has transferred to the output shaft. This is the neutral position of the motorcycle. To change into first gear, the gear dog number 5 in the output side slides toward the freewheeling gear number 1 and locks with it. Since the gear number 5 is splined, the output shaft will now spin with this gear. This is the first gear. When we change to second gear, the gear dog number 5 in output shaft returns to neutral position, and gear dog number 4 slides toward number 2 gear and locks with it. The technique is similar when we shift to third gear. The fourth gear, and the fifth gear. Please note here that before shifting from one gear to the other, the previously locked gear dog returns to neutral position first. Only then it slides into another recess to achieve power transmission. This is why there is a neutral in between every successive gear. But in real life, we find the neutral position only in between first and second gears. To understand how this happens, let's go back to our ratchet mechanism. A star shift detent mechanism is responsible for proper shifting of gears. As we can see, the star plate has ridges and valleys. A spring-biased roller rolls onto these ridges and valleys. The position of the roller at each ridge of the star corresponds to neutral condition. As we can visualize, the roller cannot rest on the ridges of the star and immediately disposes to the appropriate valley, preventing the shifting drum to stop at neutral position. But one of the ridges of this plate is ground off, as we can see here. This is done in between first and second gears so that the roller can briefly rest on this ground-off surface, thus enabling the shifter drum to stop at neutral position instead of shifting directly to second gear. The transmission system we showed here is known as constant mesh transmission system because all gears remain engaged with each corresponding gear mates at all times. In conventional sliding mesh transmission, gear shifting is done by completely disengaging a gear with one gear and re-engaging it with another. It involves complex mechanisms and drivers need tremendous skill to operate them. In addition, imperfect meshing causes gear teeth to grind and wear. The constant mesh transmission completely eliminates this problem, as you might have noticed that some gears are only partially engaged sometimes. But this is not a problem because they are not transmitting power at this moment. Only those gears which are transmitting power need to be fully engaged at that instant. We hope you learned something today. Thanks for watching.